body to fight any foreign agents.
Plants are helpful for the ecosystem.
It's an electronic device for storing and processing data.
The nervous system is all the collection of nerves in your body.
Yeast is a eukaryote.
Welcome to Spectacular Science, where it's all about science, with your host, Akshay.
Hey listeners, welcome back to this episode of Spectacular Science. I'm your host, Akshay. It's such a busy day today. I'm just walking down the sidewalk just to relax a little bit today. There are so many cars and bikes on the road. Whoa, that car doesn't even have a driver. Wait, is that a self-driving car? Wow, that is so cool. And it has this scanner thing on top of the hood. And it says the words LiDAR. Wait, I've heard of LiDAR before. It's when they use light to measure distances. And I know someone who knows a lot about LiDAR. Today, I'm going to be talking to Mr. Jack Wood from the Georgia Tech Research Institute and Electro-Optical Systems Lab. He knows a lot about LiDAR, and he works at the Georgia Tech Research Institute, where he actually makes these LiDARs that fly on airplanes, and they're just these huge LiDARs, and how they work is just amazing. That's why I'm going to talk to him. Oh, I see him standing at that crosswalk over there. Let me go say hi. Hi, Mr. Wood.
Hello, Akshay.
Hi, it's great to see you here.
It's very nice to see you too. Thanks for having me.
I know we're standing on the side of the road here, so it's a little bit noisy, but I have to tell you about something that was really cool. I saw a self-driving car driving near my house, and it was just amazing. There was no person inside of it. And what I saw was this little scanner thing on top of the car. And I was wondering what that is. And on it said like a label that said LiDAR. And I know that you know a lot about that, so that's why I want to talk to you today.
Fantastic. I'd be happy to talk about LiDAR with you.
Thank you so much. Now, can you please introduce yourself to the listeners?
Yes, my name is Jack Wood. I am a senior research scientist in the Electro-Optical Systems Lab of the Georgia Tech Research Institute.
Wow, that's so cool. So how'd you get interested in science?
Oh, I've liked science since I was before your age even. My parents got me a chemistry set when I was in elementary school. And then from there, I got a telescope and started participating in science fairs. And pretty soon it was decided I really wanted to do something in the sciences. And it turns out lasers and optics were the thing for me.
Wow, that's so cool. So what do you do in your lab?
We build LiDAR systems. So that's one of the specific things we do. More generally, we do electro-optics. So that means electronic systems that produce light or measure light. And specifically, I do optical design. So that means I can design things like telescopes or microscopes, camera lenses, or anything that uses lenses or mirrors or lasers. That's what we do.
Wow, and the lasers that you're talking about, they're not like the lasers in Star Wars, right?
Not quite, no. I tell people that you can imagine lasers are just like flashlights. You can have a really bright one that hurts your eyes, or a normal one, or even a very dim one that you could look right into. Lasers are the same way. They can be really bright and they can damage things, especially your eyes, or they can be very dim and you could use them as a laser pointer in a classroom.
Wow, that's really interesting. So, now into LiDAR. What is LiDAR and what does LiDAR stand for?
Well, let's start with a word you may be more familiar with, and that's radar. So radar stands for radio detection and ranging. And in this case, range means distance. So it's using radio waves to measure distances to things. So say from the airport to an airplane. But radio waves are really big. And so LiDAR stands for light detection and ranging. And that uses laser beams instead of great big radio waves. And so with laser beams, you can measure smaller things and maybe even further distances. And so it works really well. Another word that's similar is sonar, and that stands for sound detection and ranging, or something like that. And so it's just using different kinds of waves to accomplish the same thing, to measure distances.
Wow, that's really interesting. So what's so special about LiDAR, and how does it work?
Well, let me tell you kind of a story. Let's work up to how a LiDAR works. And I'm going to start with a tennis ball. Imagine you're standing away from a wall, and you throw a tennis ball at it, and it bounces off and you catch it. If that tennis ball, we physicists, I'm a physicist, we like to think in hypothetical situations. So imagine that tennis ball is moving at exactly the same speed on its way to the wall and on its way back. And imagine you know that speed already. Then if you measure the time it takes for that tennis ball to leave your hand, bounce off the wall, and return to your hand, you can calculate the distance to the wall. Speed is a simple equation. Speed equals distance divided by time. So if I know the speed of the tennis ball and I measure the time it takes to bounce off, I can calculate distance. If I know two of those three things, I can calculate the third. And then you divide by 2 because the tennis ball went to the wall and then it came back to you. So that's a way to measure distance using a tennis ball. Now, a laser rangefinder is an instrument that does kind of the same thing, but instead of a tennis ball, it sends out a pulse of laser light. That laser light will leave the device and go toward, let's say, a wall, and it will reflect off that wall and come back. Actually, it will go off in all directions, but some of that light energy will come back to the laser rangefinder. The rangefinder detects the light when it comes back. It measures the time it takes for light to leave, hit the wall, and come back, and it knows the speed of light. That's a constant. Therefore, it can calculate distance. So a laser rangefinder uses that tennis ball idea to measure distances using pulses of laser light. A LiDAR takes that idea to the next level. So imagine taking a laser rangefinder and measuring the distance to the wall, and then moving over a slight degree, a slight angle, and measuring again, and then doing that over and over and over and spinning around. That's what a LiDAR does. It takes that distance measurement and moves it around and scans the area, and then a computer will build up a 3D map of your environment, of what's around you. So that's how LiDAR works, from tennis balls to laser pulses to distance measurements and 3D maps.
Wow, that is so cool how it just spins around and it measures all the things around it.
That's right. It's a scanning system.
Wow, like a printer or a scanner.
Something like that, yes.
So what is LiDAR used for, and what does the future of LiDAR look like?
Well, LiDAR actually has a lot of uses, and it shows up in a lot of places, surprising places maybe. Civil engineers, for example, can take a LiDAR system out into the world and start doing measurements and build up a 3D map in the computer of an area where they would like to build a road or a bridge or a building. And that helps them know the lay of the land, if you will, and what's in the way, how much space they have, maybe how much bulldozing needs to be done, something like that. So that's kind of I'll call that a medium-sized environment. My group at the Georgia Tech Research Institute builds big LiDARs that fly in airplanes or helicopters. We fly along way up in the sky, and we scan the ground with those laser beams as the aircraft moves along. And we build up maps of the ground and even down into shallow water. So the laser beams can penetrate down into the water, reflect off the bottom, and come back. And so we can get a measurement not only of the hills and mountains and valleys on the land, but also any features that might be below the water surface and how deep the water is. In the same idea, satellites use LiDAR and create bigger, broader maps of terrain, of mountains and valleys and so forth, glaciers, rivers, lakes, and so forth. So I said the civil engineering was kind of a medium-sized space, but what these maps I'm talking about now, we're talking about very large spaces. But the idea transfers to even small spaces. Some of the newer iPhones have LiDARs in them. And I haven't really studied how they work exactly, but I'm pretty sure it's the same idea. And you can use them to create smaller maps of smaller spaces, or maybe build a 3D model in a computer of an object that you want to study for some reason. I have seen police units use LiDAR to do crime scene investigations, so forensics. So what used to, police would come in with cameras and measuring tapes and take a lot of measurements and a lot of pictures of a crime scene. Now, within a few seconds, they can set up this LiDAR and it spins around and bursts the laser beams and creates a 3D map of a room, say, where a crime was committed, or a traffic scene where a wreck happened. And then they can go back and do measurements on the computer later. If they have another question, they can follow up with stuff like that. There's all kinds of applications and uses currently of LiDAR system.
So you know that self-driving car that I saw? Does that also use LiDAR?
I'm going to put that in the future use category because yes, that's going on as a research tool. Companies who are trying to make self-driving cars, some of them are trying to use LiDAR as one of the sensors that will help the car know what's around it, so it doesn't run into another car or a tree or a signpost or up onto the curb. And so the LiDAR scans around, completely around the vehicle, and gets constant measurements of the world around it. And so it can keep up with what's there and not run into it. Now again, that probably would be used alongside other instruments, other sensors, like cameras, 3D cameras, maybe radar, maybe sonar. I'm not quite sure what all the technologies are being used, but LiDAR is one of them that you may see someday when self-driving cars become more common.
Wow, that is amazing. It's so cool how LiDAR is used in so many things, even in iPhones. It is so mind-blowing to think that this very complex technology is in the world around us. And I'm sure there's a lot more technologies that's going to come up in the future that involve LiDAR. Like you said, self-driving cars. I am so excited about that.
Me too. There are other applications. You can imagine using something like that iPhone LiDAR to be a scanner. You could scan an object and then take the model, the 3D, mock-up of that thing in the computer, send it off to the 3D printer, and there you go. You've created a duplicate or a replica.
I know, it's so cool.
That sounds kind of fun and maybe a neat experiment to do in your school or at home. But think about it. Can you think of places where you might need to 3D print something that you couldn't bring with you on a trip? Say you're on a ship sailing around the world. What about a spaceship? What if you're headed to Mars to do research or to build a colony there? You can't take everything with you that you need, but you could take a 3D printer, and maybe a LiDAR could be used to scan something, create a 3D model that then gets turned into a 3D thing that you print when you need it. I think that's pretty exciting.
Yeah, it's really exciting. So what advice do you have for kids who are interested in science?
Definitely do your homework. Keep studying. But these LiDAR systems are not just about lasers. It's about mechanical engineering. If I want my laser to spin around and scan the area in all around me, I've got to have some mechanical stuff going on in there. Some a motor, say, and some ball bearings and all kinds of things. It gets really hot when those things move around. So managing heat is something a mechanical engineer does. I certainly need help from an electrical engineer to do all the wiring and make sure I have enough electrical power to power the laser and the detectors and so forth. Then I need a computer scientist to help me interpret the data and turn it into a 3D world on my computer. So my advice is, whatever you like to do, be interested in more than one thing, and more importantly, know how to work in a team, because building any kind of technical thing takes a group of people with all different backgrounds to accomplish that thing you want to build, like a LiDAR. So whatever you're interested in, learn that and learn it well, but also get to know some other folks with some other skills.
Wow, teamwork really makes the dream work. Thank you so much for talking to me today. I really enjoyed it and I learned so much. Thank you so much. Should we take a ride in this self-driving car? It looks a little risky, but I trust LiDAR.
I trust it too.
Great. Thank you so much.
Thank you, Akshay.
Thank you so much for listening to this episode of Spectacular Science. Spectacular Science is produced and hosted by me, Akshay J. Raman. Our theme song is by Charan Ramachandran. Special thanks to Mr. Jack Wood for accepting this interview invite. I learned so much, and it was so much fun to talk to you. Thank you so much. Visit spectacularsci.com to find interactive activities, articles, and blog posts. You can also find all of our episodes and ways to subscribe to this podcast. That's spectacularsci.com. Please subscribe wherever you're listening right now. It really encourages me, and you'll get all the episodes automatically. Thank you so much for all your support. Thanks for listening to this episode, and we'll see you on the next episode of Spectacular Science. Keep thinking about science.